Good morning, everyone, and welcome to another Triangular Talks session. My name is Shreya Kalyan, and I'm the CEO of Agora Math Circle. So, before I get into Triangular Talks, I just wanted to introduce you guys to Agora Math Circle. Agora Math Circle is a 501c3 nonprofit organization started in 2015 with one class and two students, myself and another friend. And we only started in our garage. Now we offer classes in 3 different areas: Math Circle, Test Preparation, and Engineering Circle every other week. Math Circle offers math classes both online and in person at El Camino Real High School. And we offer classes in 6 different levels: Junior Beginner, Junior Intermediate, Junior Advanced, Senior Beginner, Senior Intermediate, and Senior Advanced that help students grades from kindergarten to 12th grade. We also have a test preparation student program for students 9th grade and up, and there we offer PSAT training. And finally, we also have an engineering circle where we have one class right now, which is Introduction to Data Science using Python. Right now, we serve around 600 students, both online and in person, with 150 student and parent volunteers. Our main goal is to help students find the problem-solving and critical thinking skills they need for success in both the academic and real world. We have a YouTube channel where I and many other student volunteers post videos on our math lectures very frequently under the name Agora Math Circle. We also have a website, which is www.agoramathcircle.org. And now for Triangular Talks. Triangular Talks is a forum for students to interact with and hear directly from industry executives across various companies and organizations about how they use STEM concepts and problem-solving skills in their day-to-day work lives. Triangular Talks will be a series of 1-hour online Zoom sessions consisting of 3 parts: an introduction, a presentation, and a Q&A session. These talks will revolve around one central idea: the triangular method for solving problems. This method begins with the problem, and from that one gets innovation, which one will finally use to solve the problem. To help students connect the dots between classes and real life, speakers will be asked what they do every day and how they apply their knowledge of STEM and problem solving. This will introduce students to different industries and motivate them to nurture their problem solving skills and not give up. Now, I mentioned how we have math classes, and I teach the senior advanced class. And the most common question I get asked is, why are we learning this? Or when will we ever use this? So hopefully this program will answer those questions and encourage students to take the initiative to learn and do more. Now, for our actual topic of today. Cars are everywhere. Either you or your parents use them every day to get to school or to work or anywhere else. But have you ever thought about how we got there? Well, I did some research, and the first wheels were made in ancient Mesopotamia for potters to help shape clay. And this was around 5,000 years ago, more than maybe. Now wheels come in all sorts of variations. I've even seen like viral videos of cars that have triangles for wheels, which is kind of trippy. Anyways, here to speak about innovations such as these are Ms. Sangeeta Theru and Mr. Kanak Soundrapandiyan. Ms. Sangeeta is a senior manager in the verification and validation platform. She leads a global team responsible for the development and deployment of virtual test platforms for automotive embedded SW development and testing in the propulsion, ADAS, infotainment, and body domains. Mr. Kanak is a problem manager in connectivity and infotainment. He manages the integration of radio features and ensures proper deployment across programs. He engages in cross-functional interactions with various stakeholders for alignment on feature development and delivery. Ms. Sangeeta and Mr. Kanak, thank you for joining us this morning, and the floor is yours.
Great, thank you so much. I think Heidi will kick off the presentation. Let me go ahead and just share my screen. Can everyone see my screen?
Yep, we can see it.
Shreya, thank you very much for inviting us here today. It's amazing the programs that you're involved in, and we're just super excited on behalf of Stellantis to be here to talk to you about automotive. So just can't see your screen yet, Sangeeta.
Give me 1 second. Let me go ahead and share again. All right. I may have some, while I'm waiting, maybe Kanak,
Can I share?
Yeah.
You want me to share? Okay.
Or I can share whatever. Go
Yeah,
ahead, Kanak.
I'm doing it now.
Okay, thank you.
Can you see my screen?
Yes.
Okay.
And
Let's
scroll up a couple slides. All right, so again, we are supporting this event today on behalf of Women of Stellantis Connected in Technology. Next page. So today we're going to talk about, we're going to do our introductions, and then we're going to talk about, are you automotive savvy? We're going to do a quick Menti questions, and then we're going to move into auto insights and trends, and then talk about a problem statement around safe lane changing. Next slide. A little bit about me very quickly. I've been with the company my entire career, graduated from college and moved right in and been in automotive at Stellantis, formerly FCA and Chrysler, and have had many different roles in the company, very technical roles in autonomous vehicles, vehicle safety and regulatory compliance, internal controls over financial reporting. Next page. Sangeeta, would you take a quick moment to introduce yourself?
Absolutely. Again, I'm very glad to be here to share our experiences, our problem-solving skills that we use day to day in this forum. My name is Sangeeta, and I lead the verification and validation platforms as a part of the software organization within Stellantis. I've been with Stellantis prior to this Fiat Chrysler for almost 12 years now. And I do have a degree in controls, software engineering, instrumentation and sensor engineering. And I did major in biomedical engineering. So you all will be wondering how a person who has a major in biomedical ended up with automotive. And I think it's the fundamentals of problem solving. I use that fundamental every day, day to day. Okay. So I think we're going to give you some insights into how to use that knowledge, how to use that ability, skills, in order to go from domain to domain or field to field. Okay. With that, I think we can go to Kanak.
Hi, my name is Kanak Soundrapandiyan, and a big welcome to one and all, to the student team in California, and also to our Stellantis friends who are joining with their families. So we are all very excited to be here today to give you some insights about automotives. And we hope that this information will be very helpful for you to get an understanding about automotives and their functions. So we look forward to having this talk with you. And just a quick some background about myself. I'm a program manager on the connectivity and the infotainment side. So I manage the delivery of the features across the various programs. And I got a MS in engineering, and I've been with the company for about 13 years now. Thank you.
So a little bit too, I also welcoming the Stellantis families that could come. My son is here, two of my sons actually, Carson, he's 17, and Austin, who's 14. So we're really excited to teach students more about automotive. So a little bit about Women of Stellantis. So Women of Stellantis, there's 5,000 members globally in Women of Stellantis across 37 countries. And we have a chapter within Women of Stellantis called Women of Stellantis Connected in Technology. And our vision is to connect and develop women across the company and share knowledge and experiences in technology. Our mission is to engage, advocate, and connect women in technology, promoting inclusion, to develop professionally and become leaders both at work and in the community. So what's our impact? We want to increase connections with women in tech across the globe, expand knowledge about our Dare Forward technologies. We want to showcase women in key tech roles, and here with you today, inspire young women and students in the community to pursue tech careers. Next slide.
All right. In order to kick off this entire talk and presentation, what I would like to do is run a quick automotive quiz. This is going to get you all excited. It's got some fun questions. So go ahead and join the quiz on Menti. This is the QR code. So if you can all grab your phone or even any kind of device that can read this QR code, you will be entering into the quiz. And I will be sharing my screen in a minute, and we'll go through the questions and have some fun. All right, can you all see my screen now?
Yeah, we can see it.
All right. The first question, what was the first car in the world to be mass produced on a moving assembly line in a factory? I'm just going to give it a couple of seconds for people to start entering their answers, and then we will look at what the correct answer is.
So we had a question here to go back to the QR code.
Oh, okay. Kanak, do you want to share the QR code again? I think I have the challenge with presentation. That was the...
Yeah. All right. Can you see the QR code?
Maybe we'll stay here for a minute, and then we will transfer to my screen.
Yeah, I think we should be good. You can go to your screen.
Okay. All right. We have a couple of answers here. I'm going to go to the answer key. All right. So Ford Model T was the first vehicle to be mass produced by Ford Motor Company on an assembly line. It set the ground for mass production of automotive vehicles. Okay. Excellent. I think we have good answers here. The next question, the first official motor race in the world was held in which year? Nice, I do see the answers coming in. All right, I'm going to show the answer here. Well, it was 1895, and that's the answer. The next question. The Volkswagen Beetles, I hope you guys have seen one of this on the road, got its name from the curved shape it has. What is the benefit of it? All right, we have a considerable number of answers here, and the correct answer is to reduce air resistance. I am so glad to see a lot of people getting the correct answer here. Excellent. All right, question. Aston Martin customized a car for Prince Charles to run on which special fuel? All right, we have quite a number of answers come in. You will be surprised here. It's wine. I know the very obvious answer. I got it marked as hydrogen first, but then, yeah, it is wine. All right, ABS. It's an acronym. It's a safety feature in many modern car models. What does it stand for? All right, excellent. I think the answer here is anti-lock braking system. All right, this concludes our quiz part of it. Excellent. I think this shows that the audience here is very well aware of the automotive world. So again, I think the rest of the presentation will definitely excite you with respect to how the basics of automotives, or even the topics that we're going to talk about, a specific problem statement that we are going to be presenting here. With that, Kanak, I think you can take over.
Thank you, Sangeeta. Oops. All right, I'm stuck in the screen. Okay, there you go. All right, so let's get started here, and let's take a minute to talk about Stellantis. Who's Stellantis? It's the company that we work for, and it's an automotive company that is in process of transformation into a tech and a mobility company. So it was established in 2020, and as a merger of two existing companies, PSA, Peugeot Automotives from France, and Fiat Chrysler Automotives that had operations in Italy and North America. So they came together, and Stellantis was formed. And right now, as it stands, it's the fourth largest automaker in the world. So they sell in almost 130 plus countries, and they are capable of producing about 6 million units a year. So the company is huge, and right now we are having 14 brands, and some of the brands are very iconic, and they have quite a bit of history. They've been around for almost 100 years. So that's the kind of background that some of these brands have. And again, one other point is 14 brands is a handful. No other automaker has got this many brands. And managing this is a challenge, but we have technical centers around the world, and they help in the design, coordination, and collaboration to make this all happen. And two other important points we also want to touch upon is our vision and the values. So when we talk about vision, it's like a goal that we have in our life or a career, and it's like, what do we want to do? So the vision for Stellantis is very simple, but yet very powerful. So we lead the way the world moves. That's a vision. And in terms of values, it's like the principles that you need to follow to get to your vision. So think about it as a road or a pathway that you need to create so that we can achieve your vision or goal. So in our case, the principles we like to follow are we are customer centric. So what it means is that we take care of the customer. We do the right things for the customer. That sets up us to win, and so we win together. So what it means is that we work as a team. So we have thousands of men and women in this company. So we collaborate in everything we do, and what we accomplish is as a team, and that helps us to win. And so we are agile and innovative. So again, being on the West Coast, I think you all know the importance of innovation, how important it is to be innovative, how important it is to be a part of the innovative cycle, so that is important for a business to succeed. And last but not the least, we care for the future. So what it means is that when you are in a business, you always have to look out for the next 5 years. So it's not about today or tomorrow; it's about the future. And all the things we need to do is to plan to make sure that we can survive in the future. So that kind of sums up who Stellantis is. I just wanted to give you a quick background so that you understand about our company. Okay, so with that, we jump into the details here. So when you talk about automotive systems, so we all know that there are hundreds of parts, but they can be classified into the following main systems. So we call them the body, chassis, interior, and powertrain. So all these systems, they come together, they work as one unit, and that's what you get as a vehicle. So in short, I can say that these systems define a vehicle. They give character to a vehicle. And when you look at the brand of each vehicle, each one has got its own character. So no two brands are the same. There is a differentiation, and those characteristics are defined by these main systems. So you can think about these systems as a knob that the teams can play around with to define whatever character they want the vehicle to have. And that is the principle of a brand on a vehicle. And in engineering terms, we call it the vehicle attributes. So what we do is we set targets for these attributes, and the team will go and design and deliver to these attributes. So we'll talk in detail about these four primary systems here. So the first thing is the propulsion. So the thing is, for a vehicle to move, it needs an engine. So the energy is created in the engine, it's transformed in the engine, and that's what again creates whatever is the energy needed for the vehicle to move. And what we have today is called as an internal combustion engine, which is the ICE. And the industry, as you all know, is in transition. So the ICE is being replaced by electrification. So we have these electrification vehicles, which are called as the BEVs, or the battery electric vehicles. So we'll talk about the BEVs in another upcoming slide. But let's talk a little bit about the ICE, or the internal combustion engine. So on the right, you can see an animation of how it works. And so we got the engine, and so there are pistons that are moving up and down. And the energy to move these pistons is created by a process called as a combustion. And so the combustion is nothing but, think about it as a mini explosion. An explosion happens when air and fuel are mixed together. And that energy is what moves the piston up and down. And this happens across all the cylinders. And this motion is converted into a kind of a rotary motion that helps to propel the vehicle. So what comes out of the engine is like a power and a torque, and it gets translated on the vehicle side into velocity and acceleration. So on the cylinder, you got on the engine, you got various kinds. You got a 4-cylinder, you got a 6 and an 8-cylinder. And for bigger vehicles, they use a 8-cylinder. And obviously, more power and torque comes out of the bigger engines. And the flip side is, fuel economy. So bigger the engine, the more cylinders it has, the lesser will be the fuel economy. So this is a very short explanation of how the engine works. So the next system would be the body. So when we say body, this is the outer shell of the vehicle. And this is made of steel most of the time. And you got different grades of steel. You can see looking at the colors, the various types of steels that are used in constructing the body. And recently, there is other materials that are being used, like aluminum, magnesium, and a carbon fiber, but they are more expensive than steel. And the one function, or the main function of this shell is to protect the occupants in the event of accident or a collision. And one example I want to give you is like a NASCAR race, where you must have seen cars going at in a high rate of speed. And when there is a catastrophic incident, they run into the wall, and but you can see the car is completely crushed. But you can see the driver coming out with very minor injuries most of the time. So the shell is designed, optimized and designed in a way that it can absorb all the energy, and in the process, it will protect the occupants inside the vehicle. And on the right, you can just see a picture of how the results of the testing. And so we have an organization called NHTSA. Most of you must have heard about it. So they do the testing. And so the instrument, they put dummies inside the vehicle. They instrument them with accelerometers. They put the accelerometers at the critical locations of the dummy, like the head, the chest, and the neck, and all the critical areas. And they run the test, and they try to find they collect the data on terms of acceleration and the forces that go into the dummies during the crash. And so they do publish star ratings for each and every vehicle based on how well they perform during the test. But I think the basic idea I want to convey is that there's a lot of engineering that goes into designing these shells, developing these shells, and there's a lot, and they just play around with the different kind of materials, so we can get an optimized structure which is strong enough for crash production. And the other thing is we also need to keep in mind the weight. The thing is, the more material you add, the more heavier it becomes. So we need to keep in mind that the weight needs to be kept in check so that you can acquire the required fuel economy. So it's kind of a balance on how you want to design it for strength versus fuel economy. So the other important thing that comes into play for a body is what we call as the aerodynamics. And it's the airflow around the car. And this also plays a role in the fuel economy. And this airflow is measured by what we call as the coefficient of drag. It's the air resistance that happens when a car is moving. So obviously, it goes without saying that if you have a smoother airflow, then you have less resistance, and it means that a better fuel economy. So that's why cars tend to have a little more better fuel economy. The coefficient of drag is a bit lower. That's because of the smooth structure. And if you look at SUVs and trucks, they're a bit more squarish. So they do offer a little more higher air resistance. So their coefficient of drag is a bit higher. So it equates to a little bit of a degraded fuel economy when compared to the cars. So this again summarizes body, just information on what the function of the body is and how we design it. So the next system we want to talk about is the chassis. And the chassis has got the following subsystems. So we'll talk about that in a minute. But the main function of a chassis is to provide directional stability and also the ability to steer and brake. So you can just see that as we are going around driving, you can see how the wheels are moving up and down and how it's translating into the structure to the inside. And also the function here is to give you a comfortable ride, isolating the road inputs. So there's a lot of road loads that come in as you are driving. And one of the things that the chassis will do is try to isolate these inputs so that as an occupant, you don't feel much of these movements that are happening on the underbody. It tries to isolate them so that you don't receive those inputs. So looking into the subsystem of the chassis, the first is the suspension. And the suspension provides a balance between a ride and handling. So when we talk about ride, it's going to be softer. And when you need handling, it needs to be stiffer. So basically, they are on the opposite sides of the spectrum. So it's quite a challenge always how to get an optimized ride and handling. So they just have to go tweak around to get to some kind of a soft, to get some kind of a spot where you can achieve your ride and as well as the handling target. So handling is something you might be familiar with. It's about how the car behaves when you go like in a high speed in a cornering situation, and how well the car reacts in those kind of conditions. So the components that make up the suspension, we can kind of bucket them into two categories. The first thing is the structural components, which we call them the subframe and the links. And the second category are the tunables. And they are the springs, shocks, and the stay bars. Now we call them tunables because their values can be changed as required. And those are the enablers that help you get to your ride and the handling targets. So the team can work with these parameters called the tunables to kind of achieve their desired requirements and targets. So that is one of the subsystem of the chassis. And the second subsystem is called the steering. And most of you, I think every one of us just would see the steering wheel, but what goes beyond that, we don't know. And you can see the schematic here, which shows you all the parts involved in the steering system. And so this would help you to transfer the rotary motion of the steering wheel to the angular motion on the wheels. And there is a motor that gives you an assist to turn the wheels. And without this motor, it's very difficult to turn the wheels. So you do have a motor that's an enabler to help you turn the wheels. And the steering system is electric power steering. In the past, we used to have hydraulic, but these days it's all electric. And the advantage here is that the responses is much faster in an electric system. It's very instantaneous as compared to a hydraulic system. And the feedback is also much quicker. So there are a lot of advantages, going with electric steering as compared to the hydraulic system that we had in the past. And the last system that we have is the braking system. And the braking is evolved into the brake-by-wire using the electric system. And the advantage is very similar to what I talked on the steering system. The response is much quicker. the reactions to braking is much faster using an electric system. And on the front, what we do is from the safety standpoint, if the electrical system fails, they do have a hydraulic system. So the front is what we call as an electro-hydraulic. So the backup becomes a hydraulic system so that in the event of an electrical failure, you still have an ability to stop the car to avoid issues. So that's why the front is always carries a dual system with the electric and the hydraulic as the back. And again, this is a one-page summary of the chassis, just describing the main system and the various subsystems that are part of this chassis. So the next system is interior. And the interior is where we spend a lot of time as we are traveling. And it provides, the purpose is to provide a very unique customer experience. And, each brand is very, tries to provide its, its own experience, and it's got its own theme. So there is a lot that goes into defining this interior. There is a group called as the design office that comes up with whatever theme that we need to have for each brand, and how we need to develop this theme. Elements like the color, fit, finish. They are very particular about those kind of things. Small details. They pay attention to all the very small details that are important for the customer. Like even if you look at the seats, the fabric of the seat, the material they use, the kind of stitching that goes in the seat, the color of the stitch. So there are so many minor details that we can't even think about that is taken into consideration to develop this interior theme. And the objective is to give the customer experience. So the thing is, when we come in and we want to drive the vehicle, it needs to be inviting. It needs to something that they need to enjoy getting in. So that is the purpose that they put a lot of attention into creating this interior theme. And on the seating side, we got the single, double, and the 3-row. And the third row can be, folded down to accommodate a cargo. And the front of the vehicle is what we call as the cockpit. And again, this is another important piece for the customer experience. And this is where we do a lot of interactions as we are getting into the car and driving it. And so the cockpit components would be the instrument panel. This is the panel that you see here where a lot of the things are getting mounted. And so we got the cluster, which is right in front of the driver to communicate some of the vehicle level details. And so you got a HUD that is just on the windshield that displays some of the information that you see on the cluster, so that the driver does not have to look down and he can get the info right through the HUD. And the radio is becoming very popular these days, and it's evolved, in the last 5 or 6 years, I would say. It used to be a simple AM FM with a CD player, but I think it's become the center of entertainment these days. There's a lot of things you can do through the radio. There are a lot of features that are inbuilt into the radio. There are a lot of apps that are coming in. And so that's still in evolution. Many things are in the works in terms of what the radio can do. So it's kind of exploding. In the last 4 or 5 years, things have changed dramatically, and what the radio does and some of the features that go into the radio. And below the radio, you got the center stack. We call this the center stack, and this has got all the controls and the hard buttons for some of the functionality. And just below that, we got the console, and it carries the shifter. And sometimes you get the wireless charging, and then the cup holders and those kind of things. So again, for us, for the engineering team, the task is to design this in a way that it captivates the customer, right? That is our goal. So there's a lot of thinking going behind all these different things. Like I said, the color, fit, finish, the design of those kind of things. You can see how the designs here, they are very unique, and even the material, how they blend into these colors, they all make impact, and they put a lot of attention into those kind of details. Okay, so that's another summary of the system, what we call as an interior. And the next thing is real quick, we want to talk about the drivetrain. So we got these four type of configurations. The one is the first of the front wheel drive. So the power is coming to the front of through the front wheels. And this is the most common, I would say. Mostly the small cars and the compact SUVs have this type of configuration. And the design is also a bit compact. So as the engine is mounted on the front, the power is going to the front wheels. So it makes a compact design. And when we talk about the next configuration, the rear wheel drive, so the engine is on the front, the power is driven on the rear, going to the rear wheels. And this is typical of the sports cars, but this configuration does not work very well in wet conditions. When you have snow, you would just want to avoid driving this rear wheel drive cars. It's prone to slipping. So that's the disadvantage of rear wheel drive. Now, the next is the 4x2 and the 4x4. So in a 4x2, you have power going through only one set of wheels. But when needed, you can transfer the power and make it available across all four wheels. So when needed, it can do a switch. So trucks and SUVs typically have a 4x4. And again, the advantages in weather conditions where you need power across four wheels to help navigate so that it doesn't slip in snow or other kind of conditions. You can leverage this 4x4 to help you drive safely. So this is on demand, right? Whenever you need it, you can switch to four wheels, and whenever you don't need it, you can drive just on two wheels. And the last configuration is what we call as an all-wheel drive. And in an all-wheel drive, power is across four wheels always. Trucks and SUVs carry this setup as well. And this is preferred when you do some kind of an off-roading, when you go like a rock climbing, things like that. When you want to put it through tough conditions, you can use an all-wheel drive where power is going through all the wheels always. Yep, so that's about the drivetrain. So the next thing we want to jump real quick to be about the upcoming trends here. So looking at the future, so what we are seeing is that three main categories are going to dominate the future. The first is the autonomous vehicles. The second is the connectivity, and the third is the electrification. So let's take some time to talk about these three trends. So the first thing is autonomous vehicles. And like the name says, these are self-driving, and they minimize the need for humans. And they use the camera, the radar, and the lidars to identify the objects. And the benefits are safer transportation. And because they have these cameras and the radars, they do have a vision, 360 vision, that enables a safer transportation. And in autonomous vehicle, you also end up with traffic efficiency. So they are all can move around in a very orderly way that can help in the efficiency of traffic management. And the other thing you can also consider is the transportation accessibility. So what it means is that you don't need to own a car. You can just use a car when needed, and the rest of the time you don't need it. So that it gives you accessibility when needed with an autonomous vehicle. So some of the benefits that comes in with autonomy, but the main point is safer transportation is the key that we want to keep in mind. So in terms of the levels of autonomy, we got the different levels. So green would mean that we have accomplished this. Yellow is what we are working on. And this kind of gives you a little bit of a roadmap on what those different levels are. And level 0 is no automation. Level 1, you get a little bit of a driver assistance. And level 2, you can do a little bit of help on the assistance. And level 3 is where we are kind of heading right now. And the first automaker to get the level 3 in US is Mercedes-Benz. They have a certification to do it in Nevada. And the rest of the automakers are going to be in this year. You're going to see some more automakers jump into that. And in level 3, the vehicle can do some level of safety things, that it can take over some of the safety activity. And so that is a big jump over from level 2 to level 3. The driver still needs to be in control, but some of the safety things are possible to be managed by the automatic system. And 4 and 5 are the next frontiers, I would say. Quite some ways to go there. And so we can we expect high level of automation in level 4, and it can do a lot of the safety critical things. And level 5 is where obviously you can forget the steering wheel, but again, it's going to be some time before we get there. So we think in the next 5 to 10 years, we'll see how the technology develops, but we made some good progress, I think, in the last 5 to 6 years to get to level 3. So hopefully in the next few years, we can think about going to the end here. We'll see what happens. So in terms of how they work, they use a camera, a radar, and the lidars, and each one has got its like a pros and cons. Not one is perfect in doing everything, so you need a combination of these to help you accomplish some of the things. But technology is improving, so hopefully we're going to get better in all these hardware. And you can see that within this domain, right, in terms of detection classification, how the differentiation is between the different various hardware. And when you throw in the conditions like poor weather and the light conditions, you can just see again another factor. And also when you look at how it performs, there are so many combinations here. So that's why I say that not one can do the job. We need a combination of these hardwares so that you can get to the autonomy features that we are looking at. Okay, so that's in short about autonomy and how it works. So for next, what we want to do is we want to take you through an example, like a problem statement. How do we approach a problem? How do we solve a problem? And the steps that are involved in the roadmap, the process roadmap, I would say, on the problem resolution. So for that, I request Sangeeta to please take us through the details.
Thank you, Kanak. I will be fast here. I know we are at 12:50 and we have 10 minutes. So I think most of you guys would have started to drive vehicles. And also some of you might be actually driving vehicles every day in the road, right? So what we wanted to do is walk you through a problem statement, a safety problem statement, and how in an OEM, such as Stellantis, we go through this solution deep dive, design the solution. What does the system look like, and what is the steps that we go through from start to finish in order to get this feature up and functional within our vehicles on the road, okay? So the specific problem statement that we have taken here is, how do we address safe lane changing? How many of you have actually are familiar with the blind spot monitoring system? It's a very common feature currently in all of the modern vehicles. And it's one of the safety critical features that are available in several brands of cars, right? So almost every car manufacturer basically has this blind spot monitoring system, in short, the BSM. within their vehicles. So let's go through what is the blind spot monitoring system. And by the way, one of the first blind spot monitoring system on the Stellantis brand of vehicles was introduced in 2009 in the Dodge Caravan. That was our first vehicle back in 2009 that basically introduced this blind spot monitoring system. Interesting fact. So it is a part of the ADAS, what we call as the Advanced Driving Assistance System, or some of the systems that Kanak was talking about in the previous slide, and it is designed basically in order to prevent collision of one vehicle while the driver is trying to lane change. And it is a safety device. It is basically to alert the driver of any vehicles that are close to each other, okay? But they cannot see that vehicle in a side view mirror. I'm sure with cars earlier than maybe in the last decade or even the previous decade, when you have to change lanes, you have to actually physically turn your head to your right and left and see if there is a car on your side before you make your change, right? Before you switch your lanes. Well, this technology is primarily in order to prevent that. You don't have to do that any longer. You have the smart sensing around the vehicle in order to make you aware that there is a vehicle. So don't change lanes, or you're all set. I think there's no issue with safety. You can change lanes, It gives you an indication. So most BSM systems will only detect passing vehicles directly alongside. So you don't want the system to actually detect vehicles that are coming in front of you, right? You just want to make sure, again, we're talking about specific locations, which is called as the blind spot, which cannot be viewed by the driver while you are in the lane of that moment, okay? So this is the problem statement that we have for you, and I'll walk you through what is the process of development, how do we go through the thought process of designing, and what is the system that takes us to implementation of this, this feature in our vehicles, okay? So next slide. Okay, so system description, first thing, okay? The system consists of radars, and again, Kanak went through some of the components that we use on our vehicles. The radar, ultrasonic sensors, camera, these are all the sensing equipment in and around the vehicle that basically detect this vehicle that's in your lane or in an adjacent lane in your direction, moving in the same direction as your vehicle, okay? The outputs basically consist of three different kinds. We have visual, we have auditory, we have haptic. Visual usually consists of like illuminated icons. So you can see the picture of a mirror. And by the way, all of the vehicles at this point of time do have this feature, okay? If not, next time you're in the vehicle, when you hop into a vehicle, please make sure that you watch your mirrors, and especially when you drive, make sure that light turns on, indicating that there is a vehicle in your blind spot, okay? So there is icons, there is flashing lights. In fact, some of the vehicles, advanced vehicles, do have a video image of the vehicle in your side lanes, okay, in your adjacent lanes. And then the second one is auditory, right? When you are you turn on your indicators, and which means that you want to change your lane, okay? At that time, if there is a car in the adjacent lane in your blind spot, and you want to change your lanes, typically the vehicle sends out a chime, repeating chime, or a beeping tone, indicating, again, different levels of indication to the driver, right? That there is a vehicle, be alert, and don't change the lane. Or you're clear, you can change the lane. This is pretty much what we are trying to achieve through this system. Third one is also one step beyond the auditory, which is the haptic. basically when you actually try and even beyond the auditory, say for example, you start turning or changing lanes, you will get a seat vibration or a steering wheel alert, saying, hey, listen, this is the third level and don't do it. And usually, typically, the haptic alerts alert the person and indicate that, yeah, this is not right. Don't change the lanes, kind of thing. Okay. So beyond this, so what I've given here is simply the inputs and the outputs, right? The systems beyond this actually include even automatic braking and steering, going into some of the level 2 and level 3 systems that Kanak was talking about in the vehicles. Okay. Next slide. So system design, we have hardware and software that goes into the system. And the hardware primarily consists of all the cameras, ultrasonic sensors, on-off switches, the radar, which is on the vehicle. The outputs are light, video, chime, vibrators. And then on the other side, we have the software, the intelligence, the brain of the system. Okay. The right-hand side is what I consider as like your sensory inputs, right? Your hands. And I always go to this example of comparing this with your own body, right? You have your sensors, which is your hand, eyes, ears, which all collect this information. And then you have your brain that's actually processing all of this information. And it's basically using your actuators on your body, your legs, your hand, in order to do certain things, okay? So the analogous thing in a vehicle is sensors, similar to your eyes, ears, nose, etc. And then your hands and legs are very similar to the actuators that we have, okay, which is your light, video, chime, vibrators. On the right-hand side, what we call as the software is your brain, okay? It processes this information and it basically says, okay, the car is in the adjacent lane, don't change. It gives that indication, it processes that information, and it gives you a control output that you can actually go back to, like, or provide back to the chime or the vibrators to alert you that there is a vehicle in the adjacent lane, then don't change lanes at this time. What does, where is the software written? The software is written on an electronic control unit, ECU in short, and that's where you see this massive block in between, which is the module that is fitted, packaged into every vehicle. And typically you will find like hundreds of these ECUs on a vehicle. And as we move into autonomous vehicles, right, majority of the software is going to be on these electronic control units within the vehicle. Okay. Again, the other systems that may be involved are steering systems, braking systems. Again, that it depends on the levels of autonomous or autonomy that you want to achieve within the vehicle. Hopefully, this gives you a good idea of how complex of a system that we are trying to put together here, and also the various problem-solving statements here. We have to design hardware, we have to design software, we have to basically bring in all of this hardware and software together as a system and make it work. So let's walk through what does this process look like. We can go to the next slide. We have requirements and design for hardware and software. We have development of hardware and software, integration and validation, and manufacturing. Okay, finally, when it actually goes into the vehicle. Next slide. Okay, so what do we mean by system requirements? Okay, we have requirements such as, where do I place these actuators and sensors on the vehicle? Where do I place my radars? Where do I place my cameras? And also, when do I turn on and off this feature? Can I provide the control to a user, to a driver, to turn on this feature within the vehicle? Which I call as the vehicle operational input. The interfaces, what kind of interfaces do we provide? All of this is what is collected as system requirements. We then create a virtual design We create a virtual model of all these components. And this is pretty cool, okay? You actually have these virtual cars that we design and model that we run on cloud, okay? Everybody is familiar with cloud systems at this point of time. And we create a virtual design of the vehicle and validate it in a virtual environment prior to actually going into a bench or a system or a vehicle prototype, because building a car as a prototype is pretty expensive as compared to building it in a virtual environment and validating, is my concept correct? Are my requirements correct? Are my is my implementation of software correct? Those kind of things. You know, you do not want to go through the development process and build an actual car and figure out that the system or this software or hardware doesn't work in a vehicle. Okay, so we go through this entire virtual design and validation step before we go into the real parts, real system and vehicle prototype building to validate and test and develop again. And majority of this doesn't happen without suppliers. We are called as Stellantis is a OEM. OEM stands for Original Equipment Manufacturer. We interface to several suppliers, okay, who provide us majority of the parts that connect to this vehicle. Remember, Kanak went through the whole system, right? How does the body, the chassis, all of this. There are several parts that go through this in this vehicle, and a lot of these parts are done in collaboration with suppliers that provide us these components, okay? And then we, as an OEM, take all these parts, we connect it, integrate it, validate it, manufacture it, and deliver it to our customer who drives these vehicles on the road. All right, so we can go to the next one. I'll quickly go through the thing. I know we are 4 minutes past. Going through the development process, we have, again, I've split it up into hardware and software. We have component layout, we have architecture, molding, a lot of wiring that goes. I don't know if you guys, any of you have actually like opened up the hood of the vehicle and seen how much complexity is under that hood, you know? If not, please do that after this presentation. Whenever you have some time, feel free to go to a car and explore what goes into building that vehicle, okay? Software, on the other hand, we have architecture, we have coding, we do calibrated, parameterize this software and do extensive testing, both on virtual test properties and also on real test properties. You can go to the next slide. And then a lot of it goes into integration and validation. Remember, I talked about OEMs. We are OEM, right? We get a lot of the components from the suppliers. We integrate it. One of the major role that we play, responsibility that we have, that we provide to our customers, is the integration of all of these components, including hardware and software, and put all of this together and test it, validate it, to make sure that we are able to pass regulatory tests, pass extreme weather tests. Are we able to drive this vehicle on extreme conditions? Kanak was talking about like driving vehicles on mountainous regions, you know, the different drivetrains. When we come up with such kind of complex systems, we have to go through a series of tests that we can actually perform in order to validate these systems in the field, okay? So just to name a few here, we have the diagnostics, fault analysis, wiring tests. Just want to quickly touch upon the diagnostics aspect of it because it's very critical in a automotive system. Okay, we're talking about highly safe systems, right? At this point of time, vehicles that can operate autonomously. In order to get to that level of safety, we need to make sure that we have triple level of diagnostic functions within the vehicle. What if a sensor fails in the vehicle? What if a camera fails in the vehicle? You know, then your system, it's not reliable, right? So if a camera fails in the car, then we have to make sure that first we detect it, right? And then once we detect a failure, we have to react to that failure. Okay, so these are the different things that we have to consider when we design the systems. And again, going through the process of integration and validation. This encompasses a lot of problem solving. Again, starting with the process of what is the problem statement? What is my solution? How do I design it? How do I implement it? And how do I test it? This is the common workflow process that we use when we go through all of the problem solving strategies. Okay, so I think we can go to the next one. Finally, we have the manufacturing. Okay, once we are done with design and development, we take all of this knowledge into the actual manufacturing process. We receive parts from the supplier. We put the parts together. We package it. We build the vehicle, and then we do end-of-line testing and finally ship out these vehicles to our customers. Hopefully this example helped you guys to walk through the process here. Again, we took one specific problem statement. Just think about the scalability here, okay? This is just one vehicle, which includes such a complex set of inputs and outputs and software and hardware and all of that. We have many such features on the vehicle, and problem solving is all what we do day in and day out. Very exciting, by the way. It excites me to go into work every single day. With that, I think, Kanak, I hand it off to you.
Okay. Thank you, Sangeeta. So just continuing along on the new trends. The other thing is the mobility and connectivity. So we got this is the ecosystem. We call it the ecosystem that's it's in process of being developed. So as you can see, there are many challenging things and exciting things that are part of this development. And we're just starting to kind of scratch the surface. So we got if I go around the clock here, the vehicle to device, vehicle to vehicle, the infrastructure, vehicle to network, the grid, and the pedestrian. So the thing is, many exciting things are happening. This is already done. Vehicle to device, we already do that today. Vehicle to network is kind of ongoing right now. One example I can give you is some kind of an emergency vehicle, which is oncoming. You can detect the presence to the network and as opposed to the traditional way where we identify it. So there are some ongoing activities and things that are going to come in place here. And the rest of them, again, like I said, in process. In the next 5 years, we expect a lot of improvements in these areas. So the thing is, the picture on the right kind of shows you once these are all these mobility things, once they come into play, what kind of a world we are expecting, right? So everything is going to be talking with everything. So the cars can talk to the signals, and they can talk with each other. So it's going to be a completely different way of doing things, and this is a good enabler for safe transportation. So that's the vision. And so many, like I said, in the automotive world, these are one of the exciting things happening, and many more like this are happening. But the next 5 to 10 years, we expect a lot of development in this area. So the last thing we want to talk about is the electrification. On the electrification, these are the various categories. You got the HEV, PHEV, and the BEV. HEV is just a hybrid, PHEV is a plug-in hybrid, and BEV is a battery. And this is your traditional vehicle, with the ICE engine. So in the HEV, what you have is a traditional engine with a battery and a motor. But the battery is getting charged through the engine or by regenerative braking. It can only do a very limited amount of tasks, like it can power some of the systems in the vehicle, and it can provide some assist to the internal combustion engine. So it cannot act on its own. So the PHEV is one step higher. So the PHEV is able to drive on its own or drive on electric power for a certain distance, like 25 or 30 miles. And then once it runs out of power, the ICE takes over. And so we call this the plug-in hybrid electric vehicle. So the next would be the BEV, which is all electric. It's got a bigger battery. and you get a good range with this BEV. And here is a little bit of a picture showing the emission as we go across these different configurations. In the ICE, you get a lot of emissions. So when we go into hybrid, the level is going down, the emission level is going down. So the plug-in again goes down further. And when you go to BEV, you can see that there's hardly any emission. So this is the future. And you may have read that there are some mandates that are upcoming, and some countries they do have where it's all going to be battery electric vehicles in the next 10 years or so. So that's a transition that's ongoing in the auto industry. So we are going to roll out a lot of new products in the BEV using the BEV technology. So in the next year or so, you'll start seeing them. In terms of charging, again, I'll just keep it simple here. For the BEV, you want to use the DCFC. It's impossible to have them charged through the 240 or a 120 volt. And so this is the new, you can see a lot of the charge stations that are coming up that uses this technology, and they are directly directed towards the BEV vehicles so that they can charge faster and efficiently. So here is our electrification strategy for our company. So we're developing 4 new platforms, and so this is called as the small, medium, large, and frame, Stella frame. And you can see the amount of miles that we can get of these battery vehicles. So it's as good as a ICE engine. So like I said, new products are coming out in the near future, the next year or so. And this is like a schematic of the battery pack. And here is a little bit of kind of an animation that shows how these battery packs fit in. So they are in the underbody, and these are modular, scalable. So what we can do is you can use this battery pack the way you see them here, and you can just build any body around it. So be it a car, a truck, or SUV, that's all possible. It's just a plug and play. It utilizes this kind of modular structure, and you can fit the body on top of it and make it work. All right, that is electrification, and I think we covered the upcoming, the new trends, autonomy, mobility, and electrification. That kind of brings us to the end of our talk here. And one other thing we want to touch upon is the career opportunities in the automotive world. And as you have seen, there are many things you can do. There are many pathways. And these are some examples. These are not everything, but these are some examples of the things that you can do, and the areas, depending on the education that you have, where you can fit into the different working areas in the automotive industry. Kind of take you real quick through this one. Engineering, without a doubt, is a need for all the mechanical, the disciplines that we normally know. The mechanical, electrical, electronics, industrial, and manufacturing. So they are all used for design, development, testing, and also for building the vehicles in the assembly plants. And if you like business administration, you can support the purchasing organization. We buy a lot of parts from different parts of the world, so buyers are needed. And same thing for logistics, like the supply chain management. So we have parts coming in from, like China, India. So we need to have a good logistical network so that these parts can come in time to support all the bills. And if you are an MBA graduate, things that you can do would be on the brand side, develop the brand, come up with strategies to grow the brand, and you can do also product planning. And on the right side, you got the finance. And again, you can look at the capital structure. There's the things that we call hedging. If you have international operations, if you have currency across different parts of the world, you do hedging to make sure that you can bring it over without any losses. And we can do like a cost control that goes into defining how we control the cost of a vehicle before we sell it. And with all the new technologies that we talked about, all the software development is being managed in-house. So like ADAS and infotainment and mobility, those kind of activities, whatever software is needed to manage those things. They're coming in-house. And so it means that we are need for a lot of software engineers. So these are computer science graduates, and they can help in the software development for all these exciting features. And lastly, we also have information technology that manages the infrastructure, the computer infrastructure that is needed for all a big business like this. And again, you have several pathways that you can look at in this particular area. And again, like I said, these are just some examples, and these are just not just limited choice here, but you can do many things here in this field and in this sector. So I think we are past time, but I think that concludes our talk here. So maybe we can open it up for questions, feedbacks, questions, anything. Yeah, go ahead. Yeah, I see your hands raised. Can you please go ahead?
So
You can go first.
no, you can go first. I'll wait.
Thank you. For autonomous vehicles, you said that it minimizes the need for humans. Don't we have cars for humans to travel or go from one place to another? So what's the point of an autonomous vehicle?
Sorry, I lost the last part of it. Okay, can you come again?
For autonomous vehicles, you said that it minimizes the need for humans. Don't we have these vehicles like cars and stuff for human use?
Right. So in an autonomous vehicle, the hardware can drive itself. You don't need to have a human intervention. You don't need to use the acceleration. You don't need to use the steering or the braking. The machine can do that on its own. So what it does is that it uses the hardware, like the camera, to take some images, right? What is in front of me? So the radar can do the same thing. It will take the image and it will process the image and it makes the decision. So the machine can make a decision. It's like artificial intelligence. It can make the decision. Whatever object I'm seeing, what is it? So I need to stop. Can I go? Can I bypass? So those are the kind of decisions that the machine can take on its own, so that it can bypass the need for humans.
Thank you.
Yeah, I want to add something too here. This is Heidi Negri. When we talk about autonomous vehicles too, I don't know if you realize there's many fatalities that happen due to distracted drivers. Humans are not good drivers. We are distracted. We're eating food. We may be under the influence, or we may be distracted by other people in the vehicle. So we're very distracted drivers, which can causes a lot of the fatalities that we see. So with an autonomous vehicle, that really, we're hope one day that really can reduce the number of fatalities that are caused by vehicles. And in addition to that, it's also important to note it's about your time. If you no longer have to be constantly paying attention, hands on the wheel, using your brain the whole time you're driving, making sure that you're being the most cautious driver, an autonomous vehicle at one point can take that away from you, so you have more time back. When you're in that vehicle and you're driving a long distance, you may be able to interact more with your family. You may be able to catch up on studying that you need to do for a test, or reading that you need to do for a meeting, or preparing for a meeting that you're going to have, the following day. So there's a lot of cool things about self-driving. And in addition to that, what about those people that can't drive their own vehicle? Maybe because they have, they can't see, or because they have any type of health issues that they can't drive a vehicle. Wouldn't it be cool that they now can have a self-driving vehicle take them to the places that they need to be? So there's a lot of really cool reasons why self-driving vehicles are going to come into the market here. Oh, they're already in the market now, right? But even future technologies, L3 and L4 technologies.
Thank you.
You're welcome.
Okay, so let's go to Srinidhi.
So my question is, you guys told us that you guys use a virtual kind of simulator in cloud to run the tests and run the software and hardware before you guys put it to use in cars. So for software, I understand how you can do software in cloud, but how can you do hardware in cloud? Because isn't hardware like parts?
Yeah, I can take that question. So, yeah, I mean, again, the process of modeling the hardware is what we take, okay? So any hardware is something that we can model, and there's a lot of software out there that can take the hardware parameters and kind of like convert that into. So if you think about a hardware, right, it is a continuous system. You basically, it's a system that that has infinite parts, infinite tiny little parts, you know. But then the process of modeling is taking that hardware part and basically converting that its performance into a discrete system, okay, where you start like taking portions of it and start modeling it to represent the behavior of that hardware. For example, you can model an actuator, a motor, and again, there's software like tool chain that is already available in the market that you can use to develop these software representation of the hardware. Does it make sense?
Yes. I also have another question. So you guys told that you guys have battery packs for like electronic vehicles. So would you need to change those battery packs, or would you just need to charge with electricity? Like just charge the battery, or would you need to like change the whole entire battery pack and then put a new one?
Yeah, I
Every
can
car
take
will
that.
come. Oh, go ahead, Kanak.
No, you charge them. You know, they get you can charge them. So that is where we have the different charging levels: level 1, level 2, and the DCFC. So yeah, you can just charge them when needed, and then that helps you.
Okay, thank you.
I think we have a few more questions.
Alexander, do you want to go ahead, Alexander?
Yes, thank you. I have a question. Do you plan to electrify the whole model list of your car brands, or there will be exceptions? Like, for example, you focus electrifying like French companies, Peugeot or Citroën, or maybe like Lancia. Meanwhile, Jeep, Chrysler, Dodge will be somewhat like a mix of selling ICE engine car models or electric vehicles. Like, do you have this kind of plans?
So the strategy going forward is we are planning like I showed you. We had 3 modular platforms for Stellantis. We call them small, medium, large, and the frame. So the future is we leverage these platforms to build any brand, whether it's a Citroen or whether it's a Jeep or whether it's a Ram. So this would be the underpinning for the future model years. So it doesn't matter what brand it is, but I think the mandate, as we are maybe getting from the different countries, would be that we need to be electrified by 2035 or 2040. So I think our strategy is to start looking at the full implementation of electrification. So we call it the BEV. So, but there is, we need to keep in mind the price point. So there would be some level of plug-in hybrid as we make the transition, but I expect the cost to come down significantly over the next 5 to 10 years, so that as it comes down, it'll be all BEV. So it'll be as comparable to buying an ICE engine in the near future. So to answer your question, yes, all our vehicles will be transitioning over. I would say in the next 5 to 10 years.
Okay, thank you then.
So next is we got Kavya.
Yeah, go ahead.
Oh, yes. I just had one question about the software for autonomous vehicles. I don't exactly know how they work, but can they sometimes like take input for like driver preferences? Like maybe like a certain route that the driver would want to take, or like a preferred time that the driver would want to reach a location?
Yeah, absolutely. I think these are all requirements, right? When you talk about autonomous vehicles, for you to, I mean, again, a lot of our systems are also have an integrated GPS within the vehicle, the global positioning system. Okay. So for you to enter a desired location, a destination in your car, and then for the car to actually navigate to that location, you can, the requirements will include maybe you need to reach that location by a certain time period, or you always want to drive through a particular neighborhood every time because you have to pick up someone, on your way. You can enter all of these requirements within the and the software will basically adapt to that.
Just
Yeah,
let me
and
add.
one thing I wanted to add to that too is that there will be a site that you can go to from Stellantis, so you can see what public roadways are currently able to drive autonomously on, right? Because there's going to be times where there's major construction or it's icy out or whatever it may be. And when you go to that map, you will be able to see, okay, this is where my route I want to take, but I'm seeing that there's several places within that route where I cannot enable my vehicle to drive autonomously because it's not safe to do so. So that will, that is also taken into consideration when you enable the feature. When it gets to a section of the roadway where it's not safe, it will disengage the autonomous and expect you to drive the vehicle normally.
Okay, thank you.
I think there is one last question that we can take, which is, how futuristic is aerial vehicles? So I think by aerial vehicles, my understanding is you're talking about like helicopters. Yeah, okay. So I don't know, one thing that you can probably search up after this, starting in January 2023, Stellantis partnered with this Californian company called Archer. Okay, and one of the goals by 2025 is to manufacture aerial vehicles that can take you from point A to point B. Again, battery electric. Let's think about battery electric helicopters. Okay, and then no sound. Straight lift, straight land, those kind of aerial vehicles, aerial devices, for specifically targeting highly populated portions. Like, I think the first one that we will be planning to do is something in New York City. And this is what we are planning for 2025 year. So you can go up on the internet and read a little bit about Stellantis and Archer. Does that answer that question?
Yeah.
All right. Are there any further? I think we're way past the time. Thank you again for giving us the opportunity to present here. This has been very, very interesting. Great questions, by the way. Great questions. I think it clearly states that you guys have thought through this presentation, and the questions are very, 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 very thoughtful.
So yeah, thank you for the opportunity. I hope this information was educative, right? And so if you're thinking about STEM or having career in automotive, so these are some things that you can think about, right? So look at some of the details that we shared with you on how you can fit in, and how we can. It's an exciting time to be a part of the auto industry with all the new technologies that are upcoming. So it's just going to be exciting. So if you're thinking about something like that, we encourage you to look at it.
And I just wanted to take a moment to thank Heidi, Sangeeta, and Kanak for joining us today, spending their time to help you guys learn more about the automotive industry. I know we went a bit over, but thank you so much for answering all our students' questions and giving such an amazing presentation.
Thank you.
Thank
Have
you.
a nice
Thanks,
weekend.
everyone.
Thank
Bye.
Bye.
Goodbye.
And thank you to all the students for attending and taking the time out of a Saturday morning to learn more. Hope you guys have a great weekend, and we'll see you guys next month for our next session of Triangular Talks.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!